Welcome back to the asynchronous portion of class. Today we are going to be moving away from right triangles and dealing with how do we solve non-right triangles. You might take a second to convince yourself that this is of course not a right triangle. This isn't hidden, sneaky, add them up. I don't know what this angle actually is, but this is not a right triangle. And if I want to solve for x, given what we currently know, I cannot. However, you could solve for x. You might have seen problems like this that introduce a little auxiliary line. If this were a labeled height, let's say this were 5 feet, now we could solve for x, and it would be a little bit of finagling with some right triangle stuff. In fact, why don't you do that? Take a second, press pause, see if you can't solve for x. I'm not actually going to do it, but if I were, here's what it would look like. Get that x is around 15.74. However, that's not the way we're going to do things. And I remember I had to add this initial height. So remember, my original question was, how can we find x? And as I mentioned, given what we already know, we actually can't solve x unless I introduce that height of 5. So we need to know something new, and that's where the law of sines comes in. The law of sine or law of sines says that for a given triangle, any given triangle with angles A, B, and C, and remember we talked about they're labeled with their opposite sides, so this would be side C, that there is a relationship. We know already that sine relates to the opposite side of the triangle, right? Opposite and hypotenuse. But if we remember that sine relates to the opposite side of the triangle, that's really what law of sines draws in. It draws in this connection between an angle and its side, so angle B and side B, and it in fact says the ratio of the angles to their opposite sides is consistent throughout a triangle. Another way that I can say that, law of sines says that if I take the sine of A divided by side A, that is equal to the sine of B divided by side B, which is equal to the sine of C divided by side C. And we can choose any one of these and apply it to solve for missing sides on non-right triangles. Here's what that looks like. Here's what that looks like. Okay, so here again we have this relationship between opposite sides and their angles, the sine, and that is constant throughout the triangle. If I were to set this up, then of course that means that 53 and 13 are a pair, and so I can write this as the sine of 53 over 13, that's my constant, is equal to the sine of 104 divided by x. Now, unfortunately, for the sake of time, I'm not going to spend a ton of time explaining why the law of sines works. However, I'll post an extension if that's something you're interested in. This video is going to focus on how it works. Here, like we saw in our last video, it's a little bit of a problem that our x is in the denominator. We can be pretty fancy with it, or we can also kind of be like rough and tumble. We really can just as simply as flip everything over. If you don't like that your x is in the denominator, as long as you flip both sides of the equation, you can do that. That's my new sign I made up for flipping. And I have this, 13 over sine of 53 equals x over sine of 104. And so this is really the problem that I'm working with. Using a little bit of calculation here by entering these things into the calculator. Now we're left with a relatively simple equation that I just need to undo by multiplying both sides by 0.97. And when we do that, we get an answer that maybe you recognize from earlier in the video that x is around 15.78. We're off on the hundredths, that's just due to rounding, but this is how we use the law of sines. Okay, for your asynchronous assignment, I'm gonna make this one a little bit longer. I want you to completely solve both of these triangles, okay? So completely solve both of these triangles. You'll submit your picture of your work on this assignment. As always, let me know if you have any questions. I look forward to seeing your work.